Someone left this comment on my last video, and I really want to start there, because he's not being daft, he's just repeating what everybody out there is saying. Everybody knows anything once reconstituted has a fridge life of around 30 days. That's the key, around 30 days. Now, a few days ago, I gave you 5 reasons a peptide might not be doing anything, and one was that it turned up dead. Today is the exact opposite problem. Your peptides turned up fine, but how long have you actually got to use it in? Here's the thing though, that number is real, and it's written in an actual FDA document. The thing is though, that's not measuring your peptide. So stick with me, because by the end of this, you'll know exactly what that number is counting. And I promise, once you see it, you can't unsee it. Oh, and welcome back to Peptide Corner. I'm Tom, a chartered chemical process engineer, which mostly means I've built a career on asking, yeah, but how do you know that's true? Until people stopped inviting me to the party. And before the legal team put me on the naughty step again, this video is for educational and research purposes only, not medical advice. Also, I have to remind you, smash that like button, hit subscribe, and click the bell icon if you find this stuff useful. It genuinely helps us. And I also wanted to take this opportunity to say a sincere thank you. Today we passed our milestone 250 subscribers. Now, other channels may scoff at that, but to me, that means a lot, so thank you very much. So as we do with everything here, let's go hunt down that 30-day number. And the first surprise is it's not actually 30 days, it's 28 days. That 30 is just what 28 becomes after it's been through the rounds in a number of forums. That number comes from a rule around multi-dose vials, and the FDA's guidance puts it down in one line. The beyond use date for an opened or entered multi-dose container is 28 days, unless the label says otherwise. The CDC says the exact same thing, date the vial, bin it in 28. And somewhere between those documents and the online group forums, 28 became about 30, and multiple dose container quietly became your peptide. But here's the bit nobody goes and reads. Why is it actually 28? Because to be sold as a multi-dose container, a product has to pass something called antimicrobial effectiveness testing. And the FDA spells out exactly what that test is for. It determines whether a product prevents microbial growth if contamination occurs during patient use. Hold up, let's rewind. Microbial growth and contamination. That clock is not counting your molecule falling apart. What it is counting is how long your preservative is winning the fight against the bugs you introduce every time you put a needle through that rubber stopper. It's effectively a sterility clock, and the internet reads it as a potency clock. These are two completely different questions, yet somehow the one number gets welded together and passed around forums like settled science. And look, in process chemistry, you'd never get away with this. You don't get a shelf life, you get a stability protocol. That's this molecule, this container, this temperature, this pH. Change one of those things and you run it all again completely. So anyone handing you just one number for a whole class hasn't done that study. They're just repeating one for a specific set of conditions. So what's the real clock then? Let's have a look at the actual chemistry. A peptide sitting in solution has roughly 6 ways to fall apart, and they're not interchangeable. You can get deamidation. A side group hydrolyzes off and the molecule changes shape and charge. Oxidation, usually methionine or tryptophan taking a hit. Hydrolysis, which is essentially the backbone itself snapping. You get isomerization, which is the same atoms, just in the wrong geometry and the receptor stops recognizing it. And disulfide scrambling. The internal bonds retie themselves in wrong places, like a shoelace being done up by a toddler. Oh, and I almost forgot aggregation. This is when the molecules clump into something your immune system may decide it doesn't recognize. These are the 6 different degradation types, and which one your peptide takes is decided entirely by what it's made of, not by your fridge, and definitely not by a number somebody typed into a forum in 2019. And if you'd like the plain English version of what actually degrades one of these, I wrote a free 1-pager on exactly that. It's the free storage reality check, and I'll put the link in the description for you. Now, let's take deamidation. It's the most common one on that list. Back in 2009, a team at Genentech synthesized 306 little test peptides purely just to work out what sets its speed. And the answer they got is almost unfairly simple. The speed is governed by the amino acid sitting immediately after the vulnerable one. What about the one before? Their words, it's negligible. One neighbor, that's all. One neighbor is the difference between a peptide that's genuinely fine for 3 months and one that started dying on your drive home. Same fridge, same water, same everything you can control. So the bottom line is this: 28 days is a sterility rule wearing a stability costume. It's a real number, honestly arrived at, but it's answering a question you weren't asking. And so what about the real one? Well, 2 researchers spent 40 years on this and built over 900 peptides and found every vulnerable residue is its own molecular clock with its own half-time. And those half-times range anywhere from a few hours to more than a century. That's right, hours to a century. That's the real spread. And a review out of Genentech said the quiet part out loud back in 1993. It has to be worked out case by case for every single molecule. So there is no 30. There never was a 30. So I want to know, what number were you told and who told you? 30 days, 28 days, a website, a bloke in a forum? Put it below. And if you've not checked it out yet, I've got a full video on the other half of this, the reconstitution side, the maths, what actually happens the second the water hits the powder. It's linked right here for you. Everything else, the explainers, the blog posts, the free guides, it's all on our website now, peptidecorner.net. Until next time, keep safe, keep skeptical, and I'll see you right back here on Peptide Corner.